Hey everybody. All right, so we are live and we're going to be preparing ourselves for the chemical reactions test that's coming up tomorrow. So hopefully you've got your questions. I'm definitely going to be giving you guys some specific examples and specific questions that I'm going to come up with just to but then once we go through all those, any questions that you guys have, feel free to let me know what's going on. Okay, so let me reach down here. So I got my computer going on down here, so I can as they come in. All right, but so until then, what I'm going to do is I'm going to go ahead and get started with the first example. All right, so one of the questions that you're going to see on the test tomorrow is basically going to say, okay, equation, and you will need to write it out as an actual equation, and then you will need to balance it by the type of reaction. Okay, so make sure you've got a periodic table with you and something to write with and something to write on, and that's pretty much all the materials you are going to need. All right, so all right, let's get started. All right. All right, let's say we've got, all right, so magnesium bromide reacts with iron 3 oxide to create magnesium oxide and iron bromide. All right, so there we go. Magnesium bromide reacts with iron 3 oxide to create magnesium oxide and iron 3 bromide. So what we're going to do is we're going to take each compound one at a time and just put them into the equation. Okay, so magnesium bromide. So the symbol for magnesium is, for the sake of this, is I'm going to put the answer in a different color. Separate things out for you. All right, so magnesium is Mg. It is in group 2, so it has a charge of +2. Bromine is Br. It's in group 7, so that has a charge of -1. Okay, and so remember, when you got, if the charges are the same number, then you just need one of each, and then you can move on. But in the case of like where the charges are not the same number, we're going to switch them to get our formula, right? So this becomes MgBr2 bromide. Then it says reacts with, so there's the plus. And then we've got iron 3, symbol for iron is Fe. Right in the name, the Roman numeral is the charge. So this is a charge of +3. Oxide, so that's oxygen. And oxygen has a charge of -2. So once again, the charges are not the same, so we're just going to get Fe2O3. All right, so what I'm going to do now is I'm going to erase out all the, a little easier to read. Okay, so far we've got MgBr2 plus Fe2O3. So that's the magnesium bromide reacts with iron 3 oxide to create. All right, well, to create, it's the arrow. Okay, the next one, magnesium oxide. All right, so magnesium is Mg. Oxygen is O. Magnesium has a charge of, oxygen has a charge of -2. Okay, those are the same numbers, so therefore just one of each. So MgO. Then it says and, so there's the plus. Iron 3 bromide, so iron is the charge of +3. Bromine is Br with a charge of -1. Okay, so those numbers are not the same, so we're going to switch them. We get FeBr3, like so. All right, so once again, I'm going to erase out the charges to make it a little cleaner. All right, so we've got this, okay, MgBr2 plus Fe2O3, GO plus FeBr3. That's basically taking all of these names and just writing out the formulas. Okay, so that's the first part of it. The second part, to balance it. Okay, so we've got, start on the left and just kind of work my way. So I've got one magnesium here, one magnesium here, so we're fine. Okay, bromine, I've got 2 on the left. Okay, so here we have another example where you have an even number on one side and an odd number on the other side. Okay, and what do we do when you got that even odd situation going on? Right, we double the odd number. So right here, I'm going to put a 2. So I'm going to double that odd number, so that makes that 6. That means I got 6 bromines, and since I have 2 bromines here, okay, but since I have a 3 right there, that means I've also changed the number of magnesiums. Since now over here, 1 here, so I got to put a 3 in front, and that actually solves pretty much everything else, right? So 2 irons, 3 oxygens, and we're good. If you are trying this on your own and you get to the balancing part and you find that you actually can't balance it, red flag to you that says, wait a minute, maybe my formulas are not correct. Because if your formulas are incorrect, you are not going to be able to balance this, okay? Also, just as a little bit of advice on the test tomorrow, if you get to this and you find that all of the coefficients are 1, have some wrong formulas, because there aren't going to be any of them that will have just straight 1s across in order to balance. They will not be already balanced, okay? So just another little red flag for you. If you're getting 1s, okay? So we have now correctly written out this formula. We have now balanced it. Is to identify reaction. That's too bad. Hopefully that comes back on pretty soon. I can hear some of the questions here. All right, but anyway, so back to this. We got a compound there. So there's 2 compounds on the left side, the other 2 compounds on the right side of things on both sides. This is replacement. Okay. Know that this is double replacement. They're telling you guys the whole outside inside thing. If you take a look out there, I'm using the 2 right there. Okay. So here, erase this and this, and then I want you guys to try and write it out. Out. Well, then I'll give you an opportunity to balance it. Give you an opportunity to do that, and then we'll. Strong. And hopefully the stream happening. my stream over here is kind of paused. Do my best. Hopefully things will start working out. But in any case, let me get you guys an example here. All right, so let me come up with something. All right, so we've got, let's say, nickel nitrate and lithium phosphate to, let's see, that would be nickel 1 8 and lithium nitrate. So let me read that. Nickel lithium phosphate combine to produce nickel 1 phosphate and lithium nitrate. Okay, so see what you guys can do with that. And see if you can figure out doing that. I'm going to see if I can figure out the internet connection. Okay, so I'm going to try to stay out of the way so you guys can see that right there. Nickel 1 nitrate and bind to produce nickel 1 phosphate nitrate. Maybe trying that out. Try to work it out. That's it. This is riveting YouTube viewing right now. Thanks. All right, so hopefully you guys have had an opportunity to try and work this out. Get to the answer here. All right, so we got nickel 1 nitrate is Ni, and it has a charge of +1. Is a polyatomic ion from the back of your periodic table. So that's NO3. The charge of -1. We already add that to 0. So you just, there you go. Anything to that? And then it says and. So that's the plus. Phosphate. Okay, so lithium is Li, also with a charge of +1. Phosphate is the polyatomic ion O4, the charge of -3. Okay, and so since we got a +1, -3 thing, then they're not going to nickel 1 phosphate, so nickel, that's +1, is PO4. So once again, we're going to switch. 3PO4 plus nitrate is NO3 -1. Okay, so that is the correct. Not been balanced yet, but that formulas right there. For this, need to try that. Okay, so I'm gonna give you guys a little bit, a few seconds there to try and figure that out. I see what my computer down here is trying to tell me. A bad connection. I do not know what's going on this. Hey, looks like my my chat's coming back up. Hey, Ariana. Yeah, I miss you too. All right, so I will get to the activity series here once we're done with this. Yeah, we'll definitely. Okay. Okay, yeah, this is really weird. Normal for my connection here at home. Anyways, okay. Sorry. All right, so let's go ahead and balance. So 1 nickel here, 3 there. So we'll put a 3 right there. Okay, and that means we got 3 nitrates here. So I'll put the 3. Okay, 3 lithiums. Well, there's now 3 lithiums there. 1 phosphate, 1 phosphate. So we're good. So you balance it with a 3, 1, 1, 3. Okay, so that's how you balance. And the type of reaction, once again, this is a double replacement. Okay. Keeps getting disconnected. All right, you know what? I'm just gonna push on through. We're just gonna do our best in spite of all these technical difficulties, and I really apologize for that. Just don't know really what else I can do at this point. So, all right. So, 2 examples of what to do with that now. Let's move on to a single replacement reaction. And for this, we also need the activity series that's on the back here. Okay, so I'm going to put a couple of examples up here. All right, I'll change colors, just to make it a little more interesting for me. All right, let's say of so that's zinc plus potassium chloride gives us what? Let's do cobalt, formic acid, and one more. Let's do silver plus gold to. Okay, so our job here is to predict the products of what's going to happen with each of these reactions. So what we do is we take a look at our activities, and if the metal that is not in the compound, okay, so if the compound on the list compound, then it will react. However, if the metal not in the compound is lower on the list, then nothing's going to happen. So in this first example, we got zinc and potassium. So the question is, list then potassium. It's right up at the top, and zinc's about halfway down. So zinc is definitely lower on the list than potassium. That is a no reaction. All right. Next one, we got cobalt and the hydrobromic acid. So the question, cobalt than, and the answer is yes, it is. Cobalt, even though it's pretty low on the list, cobalt is higher than hydrogen, so this will react. And now we need to figure out what the products are. Okay, so we're going to take, we got to figure out, is it going to bond to the hydrogen, or it's actually very simple. You don't have to pick because it's only going to bond to the bromine. Now, why? Is a positive ion, so they're not going to. The only possible answer here is bond with bromine. Okay, so I'm going to take cobalt and here. Wow, look at that! I just picked all transition metals here. All right, we're going to say that cobalt here is cobalt 2. And then down here, we're going to say that silver is silver 1. Okay, so anyway, so cobalt and bromine are going to go together. Is +2. Bromine is -1. So therefore, COBr2. Now is it? But it's not, because remember, hydrogen is one of the 7 diatomic elements. Is H2. Now, if you have the diatomic elements, hydrogen up here, nitrogen, chlorine, bromine, iodine, for 7 diatomic elements. Okay, make a difference, especially when you're trying to balance stuff later on. Okay, all right. We got silver 1 with the gold 2 oxide. So the question is higher on the list than gold. And even though silver is way down to the bottom of the list, well, gold literally is the bottom of the list. So yes, silver is higher, and this will, silver is going to then bond. So if silver is +1 and oxygen is -2, O, gold. Okay, so that's how it's going to work on that. So with that in mind, let me give you guys a few examples to work. Okay, so magnesium plus two oxide. Going to happen with let's say calcium chloride. What's going to happen with that one? And just for good measure, let's come up with another one. 2 plus chloride. All right, so take a moment and try to work that out and see if you can figure out what the products are going to be. All right, so I'm going to give you about a minute or so, show you guys the answers. All right. All right. Ouch, I just dropped quite a few viewers. All right, let's go over the answers here. So, question here is magnesium higher than iron? And so yes, magnesium is higher than iron, so this will react. MgO. And over here is then, well, no, it is on the list, so there. And then is calcium higher than sodium? Well, yes, it is. So this will react. All by okay. And while we're at it, since we've got some single replacement reactions on, let me take a quick little moment to explain redox reactions. Okay, so if you remember, redox reaction is a reduction and oxidation, and there actually is a very easy way to identify what is reduced and what is oxidized without to do all the fancy calculations with the charges and everything. And really all you have to do is the of what they are. So oxidation is the corruption of a metal. So in other words, out as an element and it ends up in a compound. So element to compound, that's oxidation. Is the purification of a metal compound and ends up. Okay, so if we look at this equation right here, you quickly easily notice that is going from a compound to a, so iron is being reduced, it's being purified, and then magnesium starts out as an element and it ends up in the like this, and it just says, okay, so what is the what's oxidized, what's reduced, and you'll be able to justify your answer. You could actually totally justify it by saying, okay, well, calcium is oxidized because it starts out as an element and goes into a compound and it's being corrupted. That's oxidation. And then you could say sodium is reduced because it starts out as a compound and ends up as an element being purified. Therefore, that is reduced. All right. Let's see. There are two more things that we definitely need to get to before we wrap things up here. All right. The next one really is just to be able to identify a action. Okay. A few examples up here on the board, and let's get them to change colors. You know, just cause. All right. Plus 2 yields low. Okay, I'm not going to worry about balancing these. These a bunch of them on here. 6 plus 2 yields CO2 plus H2O, and then copper plus silver nitrate gives copper plus silver. Need something like Fe2O3 Fe plus L plus NaOH What does it give? NaCl plus O. And if I go, any of you guys would be able to see it. Let's go ahead and try it. Actually, no, I don't. Let's not risk it. All right, so I've got examples here, and let's talk about the type. Okay, it's really quite simple. I'm looking at the elements that are involved, except for one of them. Really, what we're doing here is we're just looking at what is actually going on. Okay, so this top one, there's one product. That is synthesis. Okay, this one right here, this actually is the only going to be specifically looking at what's going on. Carbon, hydrogen, and oxygen. It's producing carbon dioxide and H2O. This, okay, and then we've got this. We have an element and a compound. So that is down here. There is that is equations here and saying, okay, I have different types of reactions, because that honestly would take a lot of me write out all the actions. What I'm going to push you video that I've already created for this called How to Identify the Types of Reactions. So go watch that, and then you can kind of see some different examples. And you've also been examples in class. One of your practice sheets, the one that's got the 25 balancing on one side and 25 on the other side, you practice identifying actions. Okay, so feel free to go to that. You can send me an email confused about one of them, like take a screen or take a picture of the picture. Get back. Okay, so that's identifying types of reactions. There is going to be lists, 5 of them, and yes, I know there are 6 different types of reactions. 5. You will have to identify. Okay. Okay. Now, here's the last thing. Sure, before calling it quits here, and going to ask a series of questions, and in equation, you will need to identify what is wrong with it. You need to write it correctly, and then you will need to write it out, basically. So you're going to name the so just your class series of questions right there, where that's what it is. Walk you through it, and that'll be it. Okay. Let me come here. I got a little distracted. All right. Let's say we have CaCl2 plus K2 yields CaNO3 plus all right, look at this equation. Are quite a few are wrong with it. So let's go through. Let's start with or sorry. So sodium is in group 2, so it has a charge of +2. Chlorine, so it has a charge of 1 and 2. So this formula actually. The next one, K2NO3. Well, potassium has a charge of nitrate, has a charge of -1. That's a plus. We only this formula is incorrect. Correctly, okay, well, we already know that this one's right. So CaCl2 plus, but since we only need really only KNO3, now over here, CaNO3 too. Ca nitrate is -1. Okay, well, so no, that formula actually is written correctly. CaNO3 2. Yeah, so okay, Cl -1 is so plus. So like, because you're gonna have to write out what's wrong with it. So there are two things wrong with this equation. Formula was written in, and then the second thing that's wrong with it is that it's not a balance. So we are now writing it correctly. We now have the correct. Here we're going to balance this. Okay, so I got 1 calcium on the left, 1 calcium on the right. So that's fine. Put a 2 right there, which means I now have 2 potassiums, and only 1 here, so I need to put a 2 right there. Also gives me 2 nitrates and 2 nitrates. So now everything is completely balanced. So I have taken this formula or equation, identified that this formula was not written correctly, and now I'm balanced right out as a. So here we go. That is chloride. So I'm going to say calcium chloride, and so KNO3 is because they produce, creates, yields, whatever you want, because that's the arrow. That's CaNO3 too. That is nitrate and potassium chloride. Okay. And that's pretty much how you're going to do it. Okay, so you're going to be given an incorrectly written equation. You need to go through each formula to make sure that the formulas are written correctly, identify what's wrong correctly with the correct formulas, and then you balance it, write it out. So basically, take the formulas and write the names and put it into a sentence format. Okay? And again, for an example of that, go back to your test review packet in the problem bank. At the very end of that, you've got a list. I mean, sorry, not a list, but you've got a series of questions that are exactly like that. Okay, so that's your test. You're going to have a word equation that you will have to write out what it is. So write out all the formulas. You are then going to balance it, what it is. You're going to have a redox, and you're going to be asked to identify what's oxidized and what's reduced and be able to justify why your answer is what it is. You will be given some single replacement reactions and asked to predict the products. So you're going to look at the activity series going on there. Same thing with the double replacement reactions. You're going to have to write out a double replacement reaction and then balance it. You're going to be given types of reactions, and you will need to identify what they are. And then at the very end, you'll have something like this, where you have an incorrect equation You'll need to fix it, and then write out the sentence version of it. So write out all the names, okay? Truly apologize for not being able to take any of your questions. I don't really understand what is going on. Hold on. There may be hope yet. Let's see. This has been very bizarre. Okay. Yeah. Oh, you moved to, hey Nor. You moved to Clark. Oh, you must have what's her name? Mrs. Gall. Yeah, she's awesome. I love her. I love her a lot. She's a great teacher. She's a great teacher. All right. Hey, so my chat window, hey, is finally back up. So here for a little bit, since we still got some time left. If you guys have any questions, please comment, and I will do my best to try to answer those. Okay. And now that I've said that, it just went off. Oh, I am so sorry. I have no idea what's going on. I just got disconnected. Well, it is really awkward. So, all right, I really apologize. The plan was to be able to take all of your questions. It has not worked out like that. So the examples that I've given you right here are enough. You're always welcome to go back and check the other that I've got going on. And essentially what I'm going to do is once I sign up here, I'm going to go reset my something weird. Yeah, and I'm suddenly disconnected from everything, but I'm still, I don't know, go figure. So anyway, so I really appreciate those of you that logged in and joined us. I hope this was helpful, even in the slightest little bit way. If extra help, you know, I'll be available in the morning. So if you want to stop by time between 8 and 8:45, I'll be there. If any of the other chemistry teachers are there, we'll all be there to help out and ask questions. So I guess that's really about it. So go check out all the other videos. And please keep sure to send me any questions that you guys might have. So I guess I've been signing off now for about 5 minutes, so I might as well just go ahead and do it. So thank you guys so much for signing in. I hope you guys have a great evening. All right, check you later.